Right, today's lesson we're going to be considering the inverse functions. So quite simply, the inverse of a function, and we can say any function, for instance, quite simple, f of x, where the variable is x and the function being applied to it is f. Right, the inverse of the function f of x is the function that undoes what f of x has done. And the notation that we use to identify the inverse function, so if we have the function and we've called our function f of x, then the inverse function is f to the -1 x. So that's how we notate that we're talking about the inverse function. So what is it? Well, if we take some input or a range of input values, and well, let's say we have input values for t, so perhaps this could be time, and we apply some mathematical rule to it. And this mathematical rule, let's say we call this mathematical rule v. So v could represent perhaps velocity. Then what we get out the other side is the result, which is vt. Now, if we wanted to reverse what the function has done, we'd apply the inverse function. And what the inverse function does, so the inverse function here would be v to the -1. The inverse function would return us back to our variable t. And we'll have a look at this in more detail just now. But just so that we understand that we have a function, we apply some mathematical rule to it, it can be reversed, and the reversal is our inverse function. Right, let's consider a very important concept when it comes to inverse functions. So let's take our standard function f of x, and let's consider all the input values. Now, in function terminology, all the input values are what we would consider the domain of the function. Okay? Now we apply the function to the input values, and we will get our output values. And the output values in function terminology are what we call the range, right? The set of output values. Now, if we consider taking the inverse function, so the inverse function here would be f to the -1 x. It undoes what the original function has done, right? So what are we putting into the input function, or the inverse function? Well, we're taking the output values, in other words, we're taking the range of the original function and putting it into the inverse. And so the domain of our input function is the range from the original function. And if the purpose of the inverse function is to undo what the original function has done, then the range of our inverse function is going to be the domain of the original function. We need to return back to our original values. So that's very important to remember when we're dealing with inverse functions. Okay, so the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. So quite an important concept, because it will help us to work out domain and range for the inverse or the function, depending on what the question might ask of us. Right, let's consider how we would find the inverse function. So we're going to use a very simple technique called remapping. Right, it's the easiest method to use. It's sometimes when you're dealing with linear inverse functions, it's quite easy to see how to create the function. But when we're dealing with more complex functions and we need to create the inverse, it's just easier to remap them. So let's take a simple example. Let's say we have the function f of x, and f of x is equal to, let's say, 3x minus 5. So to remap the function, what we'll do is just to make life easier, we're just going to change this into y equal to 3x minus 5. We could leave it as f of x, but it's just going to be messy. So we'll just change it into y equal to 3x minus 5. What we're going to do here is we're going to remap our x and y values. So we're going to swap them around. So whatever was y is going to become x, and whatever's x is going to become y. And now we're just going to resolve for y. So in order to do that, I need to move this 5 to the other side. And then to get rid of the 3, I'll divide through by 3. So I'll get x plus 5 over 3. Okay. Now we don't have any y equal to something, right? This new function that we've created is the inverse function. And that we denote as f to the minus 1x is equal to x plus 5 divided by 3. So there's our inverse function. And if we think about the original function said multiply by 3 and then subtract 5. And so we need to undo it in the exact reverse order. So if we subtracted 5 first, we need to add 5 to undo that. And then we multiplied by 3, we need to divide by 3 to do that. So quite easy to see with a linear one, but when they become more complicated, it's not as easy, and so remapping really is quite helpful. So let's do a quick little check and make sure that we've done this correctly. So if I take, for instance, let's take the value, just for simplicity, let's just take f of 1. So what will happen if I input 1? I will get 3 minus 5, which is minus 2. Now, if I put minus 2 into my inverse function, I should return to my original value. So let's say we want to take the value of minus 2 for the inverse function. So I'll get minus 2 plus 5 all over 3. So BODMAS, I need to add the 5 first. I'll get 3. 3 divided by 3 is going to give me 1. And so I have returned to my original value. Right, let's now move on to another important concept of inverse functions. So let's consider the function x squared. So now we're not looking at a linear function, we're looking at a quadratic function. And I've just stated here that x is an element of the real numbers. In other words, a real number value for x. So we have the full range of x squared. Now let's just quickly remap this and find what the inverse function would be. So if we say y equal to x squared, just for simplicity, we're going to remap. So we're going to swap the x and the y. We're going to get x equal to y squared. And then we're going to solve for y. We're going to get y equal to, now we're taking the square root, so we have to consider both the positive and negative values of x. And right here we've hit a bit of a wall, because by definition a function can only have one output for every input value. And this over here is not a function, right? This is just a mathematical relationship, a mapping. It's a one-to-many mapping, right? If I put in 2, I would get both positive and negative 2. So does that mean that something like this does not have an inverse function? And the simple answer is, as it is, x squared does not have an inverse function, right? One of the most important things about inverse function is only one-to-one functions have an inverse. Now this can be very quickly demonstrated. If I took the inverse of this function, I'll quickly make it red so we can distinguish the difference. And this is what the inverse function of x squared would look like. This is this isn't a function, this is a relationship. This would be plus or minus squared x. You'll notice that we have now created a one-to-many mapping, and that doesn't satisfy the condition for a function. However, there is a simple way that we can convert our many-to-one function into a one-to-one function in order for it to have an inverse. So the simplest and easiest way that we would normally do this is we would put a domain restriction on the function. So if I restricted the domain of this function and I said x has to be greater than or equal to 0, right? That would exclude all of these parts of the function, and we would only be left with the increasing part of the parabola on the right hand side. And if we look closely, that is a one-to-one function, right? It only has one input and one output. And since it has one input and one output, if we created the inverse function, right, we would then only get one value. So how would we do that? Well, again, we've already remapped, we've already created the function. Now, which part of the inverse function am I interested in? So if I consider again taking this function, you'll notice there are two parts to this inverse function as well. So am I considering the top part or the bottom part? Do I need plus the square root of x or minus the square root of x? Now logically you could work out it's plus the minus or plus the square root of x. How can we prove that? Well, we just go back to the fact that we know that we have the domain of the original function, and the domain of the original function is the range of the inverse function, the range being the output values. And so if we look at the function, the inverse part here, you'll notice that only over here do we have positive values. And so for our inverse function, so if we had f of x equal to x squared, x is greater than or equal to 0, then our inverse function would be f to the negative x of the square root of x, just the positive part. And we would by default then be excluding all these values here. Okay, so while certain functions can exist, only one-to-one functions have an inverse. However, we can set domain restrictions if we need to in order to then create a inverse function. Okay, let's just look at a simple example just to end off. Here we're asked to find an expression for the inverse function. So we'll start with the function itself. We want x to be greater than or equal to -1. And we have to set a domain restriction here, because if you consider the square root of something, if we put any value less than -1 into there, we would get a negative under the square root, and we don't know how to deal with that just yet. Okay, let's change this into y equal to x plus 1 minus 5. We'll remap x and y. X equal to the square root of y plus 1 minus 5. We'll move the 5 over to the other side. We'll square both sides. And then we'll move the -1 over. So we'll get y equal to x plus 5 squared minus 1. And we don't want y's, we want the inverse. So we'll say the inverse function is x plus 5 minus 1. Oh, sorry, x plus 5 squared minus 1. There's our inverse function. Okay, now that we've found the value, or we found the inverse function, the next part of the question just says, solve the equation when the inverse function is equal to whatever the original function is when we input 35. So we'll do this in two parts. We'll first consider, well, let's say, well, we have f of x equal to square root of x plus 1 minus 5. And if we put 35 in here, we will get the square root of 35 plus 1 minus 5. Now, by definition, the square root is always positive unless we specify the negative solution. That's going to give me the square root of 36, which is 6 minus 5, which is equal to 1. So what we're saying is, well, we want to know when the inverse function f to the minus 1x is equal to 1. So that means we have x plus 5 squared minus 1 equal to 1. And we have x plus 5 squared equal to 2. Take the square root, we'll get plus or minus the square root of 2. So we have two possible solutions. X equal to plus or minus the square root of 2 minus 5. Okay, so we have two possible solutions for x. However, we need to remember that in order to create an inverse function, we can only have a one-to-one function. So one of these values is not going to be within the domain or range of either of these two functions. So we've solved for the input of the inverse function. Okay, so the input of the original function is the domain of the inverse, which is also the same as the range of the original function. So let's go back and see if we can calculate the range for the original function. Well, we have the domain. We're told that x has to be greater than or equal to -1. So that means the smallest possible value that we could put into the function f of x equal to square root of x plus 1 minus 5, the smallest value we could put in there would be -1, and that would give us -5, right? And if we put increasingly bigger values, you can see we're going to get bigger and bigger and bigger values. This means that this is a minimum value and it would go on to infinity. So the range of my original function is x is going to be greater than or equal to -5. Well, if the range of the original function is always going to be greater than or equal to -5, that tells me that the domain of the inverse function, sorry, that's not how we write the domain. The domain here would be x must be greater than or equal to -5. And if we look at our two solutions, if we took the negative square root of 2 minus 5, that would be less than -5. And so the only value we would want is x equal to plus the square root of 2 minus 5. So I hope that helps you to see the importance of understanding the domain and range, the relationship between the inverse functions, and also very importantly the fact that only one-to-one functions have an inverse, but that we can set domain restrictions to create, we can change a many-to-one function to a one-to-one function to create an inverse function.